Okay, the first problem I want to go over is 54, which uses a concept called Hess's law, which basically just says that you can add if you have a bunch of different reactions, you can add the enthalpy of each of the reactions to get an overall reaction and the enthalpy of the overall reaction. So essentially what this question is asking, let's just read it first. It says diamond and graphite are two crystalline forms of carbon. At 1 atmosphere and 25 degrees Celsius, diamond changes to graphite so slowly that the enthalpy change of the process must be obtained indirectly. Using the equations from the list below, determine the enthalpy from carbon diamond going to carbon graphite. So the overall equation needs to be C diamond going to C graphite, okay? And so we have to manipulate these equations to get this equation. So clearly we see that we need C diamond on the reactant side, right? The only equation that has C diamond is the first equation. So we don't want to change it, right? Because the carbon diamond is already on the left side as it's supposed to be. So we're not going to change that one. Let's see. We also notice that we have 1 mole of carbon diamond on the left side, which means, and on this one, we have 1 mole as well. So we're not going to add or we're not going to multiply or change the sign of this first one. The second one, though, we have to make sure that we are, so hold on, let me rephrase this. So we know we want graphite on the right side, right? So in order to do this, we're going to have to rewrite the equations in such a way that all the intermediates cancel out. And intermediates, I just mean like CO2, carbon monoxide, oxygen gas, okay? Because they're not going to be found in the overall equation. So we know that equation number 1 has to be written as is, right? So C, I'm going to abbreviate diamond with a D, plus O2 gas yields 1 mole of carbon dioxide gas. So for the next part, we also know that we have to cancel out somehow the oxygen and the carbon dioxide. And the only equations that have oxygen and carbon dioxide are the second and third ones. And we know that we would have to have graphite on the right side. So we can try putting on the right side. Let's see. So these problems really are just kind of seeing what you have and seeing what you need to switch in order to cancel out. So let's see what else we have. We have 1 carbon monoxide here, 1 here. So those would cancel out because whatever's on, you can only cancel things out that's on the opposite side. So like carbon monoxide's on the product side here. And then on in this reaction, it's on the reactant side. So those would cancel out. So let's see. What I'm going to do is I'm going to go ahead and try something. So I'm going to flip this reaction around, okay? Let's see if that gets us close to where we want to go. So it would be 2 carbon monoxides, because all I'm doing is changing it it's going from carbon dioxide to these 2. But I'm going to flip it to where it's going from this one, carbon monoxide and oxygen gas, to carbon dioxide, okay? So 2 carbon monoxide gas plus O2 gas yields 2 moles of CO2 gas, all right? So I'm not going to multiply it by anything just yet, but since we did flip it, now what we have to do is multiply this by -1, okay? Because now it's the opposite. So first it was delta H was positive, right? So it was endothermic, but now since we're flipping it, we know the reverse reaction must be exothermic. So we have to multiply it by -1. Next thing I'm going to do is I'm going to go ahead and flip the third reaction, because right now we have, let's see, we put carbon monoxide on the left, and we need carbon, this one's going to have to be flipped eventually as well, because we're going to have this on the right. So let's go ahead and actually do number 4 first, because that makes sense, right? We want to cancel out carbon monoxides. So we're going to jump down to number 4. So it's going to be C graphite and reacting with carbon dioxide gas to give us 2 carbon monoxides gas. Okay, so you must be thinking, why did he put carbon graphite on the left side? It needs to be on the right side. That's correct. It does need to be on the right side, but remember, we have another equation that has carbon graphite that we're going to switch around so that way it's on the right side to see if our math works. So since we flipped number 4, what do we have to do to the delta H? We flipped the reaction. So now that means we have to flip the sign of this one as well. So we're going to multiply it by -1. Okay. And now let's go ahead and see what we have to do for 3. So we know we want carbon graphite on the right side. So if we flip this one, it'll be something like this. You'll get CO2. This is equation number 3. Yields C graphite. Oh, I should not put. So I'll put graphite and oxygen gas. All right. So now we need to see what we can cancel out here. But the first thing I notice is that if I were to try to cancel things out, we have a graphite here on the graphite here on the product side and a graphite here on the reactant side. Those would cancel out, right? But we don't want them to cancel out because we need one graphite in the product side here. So what I'm going to do is multiply this one by 2. And that'll change all of our coefficients. So 2 there, 2 there, and 2 there. Okay. So let me go ahead and try to. And since we had already flipped it, right? Because originally Reed had graphite on the left, now it has it on the right. So we need to multiply it by negative, right? But since we multiplied the entire equation by 2, C2, 2, 2, we have to multiply this thing by -2, okay? So -2 here. Now let's see what we can cancel out. So we have two oxygen gases here on the left side. On the right side, we have 2 oxygen gases, right? And that helped us out because multiplying by 2 helped us out because now we're able to cancel out these 2 oxygen gases with these 2 oxygen gases. So that one goes, and these 2 go. Let's see, we have 1 carbon graphite on the left side. I'm gonna cross it out. And we have 2 on the right side, okay? So we can cross out this one here, and we can cross out the 2, which still leaves us with 1, right? So now we have to notice that we have a total of 3 carbon dioxides on the left side now, right? So you have one here and 2 here. So 3 on the left side of the arrows, right? So we also notice that we have 3 on the right side of the arrows. So 2 here and 1 here. So 3 on both sides. So we can cancel the carbon dioxides out. And that leaves us with 2 carbon monoxides to cancel out. So 2 COs here, 2 COs here. Those 2 cancel out. And the only things we're left with are carbon going to diamond and then the 1 carbon graphite that did not cancel out, okay? So if we were to rewrite this, it would be carbon diamond going to C graphite. And now we know that we can find the total delta H of reaction for this reaction by adding up all these delta H's. And you have to take into account what you changed. So for example, number 1, I will do in blue. So the total delta H is equal to number 1, which we did not change, right? It's the same on both sides. So, or we rewrote it the same here. So that's negative 395.4 kilojoules. And then for number 2, I'll do it in red. And we took the 500, for this original reaction, we had flipped it, right, to get this. So when you flip it, you have to multiply it by -1, so that way you get the opposite sign. So this is actually going to be minus 566 kilojoules. And for number 3, we'll do in green. We, going from here to here, we flipped the reaction and we multiplied everything by 2, right? So we, in total, we multiplied this by -2, right? So it would be, we can do plus -393.5 times -2. Let me go ahead and get these down here so we have more space. And then the last one, number 4, we'll do in orange. So to go from here to here, we flipped it and we didn't change the coefficients or anything. So that means we multiplied by -1 in order to flip it, right? So therefore, it would be the -1 would be here. And then -172.5 kilojoules. And when you add all of these up, you should get an answer of delta H to be equal to -1.9 kilojoules. And it would be, typically it would be per mole. So the units of enthalpy are kilojoules per mole. So all of these should have had units of kilojoules per mole. However, I probably forgot to do that. I made this worksheet. So that's the first problem I want to go over. If you have any questions, or just try to, if you don't understand it, try to rewatch it again. And then there's more problems on this in this practice question set. So like, for example, number 51 is, 51 is another Hess's law problem. And 52 is another Hess's law problem. And I did give into, let's see. Yeah, it looks like number 53 is a different style of Hess's law problem. You just have to write your reactions yourself, okay? And number 55 is a Hess's law. No, wait, it's not. Number 55 is not a Hess's law problem. So I would definitely check out number 51, 52, and 53 for more practice like this. This is going to be an important topic on your test, so make sure you know how to do this. But yeah, thank you. Bye-bye.